Hello, welcome to this lesson on using your TI-84 graphing calculator to determine whether or not data is normally distributed. On this lesson, you're going to notice we've got a few notes we're going to look at on the left-hand side of the screen, and on the right-hand side we have a virtual calculator that I will use to show the buttons you need to press and the results that we actually end up getting on the calculator screen. For the example we're going to work at, we're going to take this data, which was from a survey of people known to have cats. They were asked how many cats they actually have at home. And we got these results. So 58 households had one cat, 92 households had two cats in their house, and so on and so forth, up to 6 cats. This data was just made up for the purposes of this example. The first thing you want to do to determine whether or not this data approximates a normal distribution is get this data into your calculator. So I'm going to go to Stat and then Edit. I'm going to enter the first thing I see in the list, or the first list of data into list 1 and the second list of data into list 2. So list 1, I've got 1 through 6. 1, 2, 3, 4, 5, 6. I'm just going to enter them in, pressing equals in between. Then I'm going to right arrow over to list 2 and I'm going to put in my numbers of households. Your list 2 here is also known as a frequency list. It's giving the number of households that fall under each category. 91 and 35. It's important to note here that you want to make very sure that your data that you've entered into the calculator exactly matches the data you've been given in the question. If the data doesn't match exactly, your answers will turn out incorrect. Your teacher won't know where the incorrect answer came from. You could end up knowing how to do the whole question and end up with a mark of 0 on that question because of incorrect data. So I've looked through the list, I've looked through my calculator, and everything seems to match. So I'm going to go on to my next. My next step is I want to determine the mean and the standard deviation of this data. So we'll need those values later when we're setting our window. So I go to the calculator and I press the Stat button. I go over to Calc, and I want to go to one variable stats, the very first option. Our data is in L1. We do have a frequency list. It's in L2. So under frequency list, I need to enter L2. That's in blue above the 2 button on the calculator. So I press second, and then the 2 button to get L2. And I go down to calculate. And I'm going to get several statistics, but what I'm interested in is the mean, the top number. So the mean for this data is 3.31, rounded to 2 decimal places. And the standard deviation, remember you're using the little letter sigma for standard deviation, is 1.40. If you're doing this question, either following along with the video or you're doing a question similar to this later, make sure you write those numbers down as you move through because you're going to need them in the next step. So now we're going to turn on our stat plot. So we go second, stat plot. You can pick any stat plot you want. I'll usually just choose the first one. And I want to make sure to turn it on. I can see that on is blinking, but I want to hit enter to make sure it's turned on. And then I want to pick the correct type. We want a histogram, which is sort of like a bar graph. We want to pick the bar graph type right here. So to do that, I have to press arrow down to get into type. I want to arrow over until my bar graph is blinking, and then press enter, so that's the highlighted one. The other change you have to make in here is our data is in list 1, but we have a frequency list in list 2. So I highlight the 1, and instead of 1, I press second, 2, press clear, get alpha out of there, and then go second, 2 to get list 2 in my frequency chart. If I press graph right now, I may or may not see some bars with my data because I need to adjust my window. So I go to window. Now there are some very specific window settings you want to set when you're trying to determine if this is normally distributed data or not. For my X-min, I want to type in my mean minus 4 times my standard deviation. For my X max, I want to type in my mean plus 4 times my standard deviation. And for my x scale, I want to put the standard deviation. So going back a step, if I go back a page, we can see our mean was 3.31 and our standard deviation was 1.40. So my x min becomes 3.31. So I clear that out. 3.31 minus 4 times our standard deviation, which was 1.40. For y max, you want to do the same thing, 3.31 plus 4 times 1.40. And for my x scale, I'm going to put 1.40, my standard deviation. Now for my y values, y min I'm going to put 0 because we're talking a frequency graph. We're not going to have any values below 0. My y max, though, I don't know how high it's going to have to go. I want to make sure to make it high enough to see the top of the bars. So I'm going to hit graph. And I can see I have some bars here, but you can see they all go off the top of my graph. So I'm going to look back at my data. And I can see we're talking about hundreds of households. So I'm thinking I'm going to have to raise my y value quite a bit. So I'm going to go back to window and I'm going to put y max to 200. Okay. I can see the tops of some of my bars, but not all of them. I still can't see the top of that bar. So I'm going to keep increasing my y max until I can see the top of that bar. Don't be shy about increasing it quite a bit. Okay, better to overdo it than underdo it. So I'm just going up by 50, and there we go. I can see the top bar there. Okay, so I look at that screenshot, and the question I have to ask myself is, does that data look normally distributed? On this side of the screen, I've shown you what an ideal normal distribution should look like. Your teacher's already taken you through how this represents a bell curve, with 38% of the data following in the first standard deviation and one standard deviation lower than the mean, and so on and so forth. Right, this is what on the calculator a perfect normal distribution would look like. So we go to ours and we look and see, does this look anything like the perfect normal distribution? Well, for this question I would have to say no, our data is not normally distributed because it doesn't follow the pattern that you see on here. That's the end of the video. Thanks for watching.